hypothesis test. Our hypotheses are given. The null is that p is equal to, less than or equal to, 0.19, and our alternative hypothesis is p is greater than 0.19. So we're given the summary statistics. Our sample proportion is 0.2, n, our sample size is 120, and the significance level at which we're going to test the claim is 0.01. So here we're going to answer the following questions. So what conclusions should be drawn? So we're going to step through the process. Determine the critical values of the test statistic. Well, here we're doing a one-sided test, and that one-sided test we need a significance level of 0.01. So we need a p-value equal 0.01, arguing greater than. So since we're doing a proportion significance test, we're going to be doing a one proportion z-test. And so I'm going to be doing this based upon the standard normal distribution. So to calculate the critical value, I'm going to do this. I'm going to press stat and use my calculator for the normal distribution. In this case, the standard normal distribution, mean 0, standard deviation 1. So these are my z, this is my z distribution. And so I want to calculate the probability of being greater than some value, but I want that upper tail probability, I want the percentile, this number, which I don't know, to have a probability of being greater than or equal to that number, of being 0.01, the significance level. So if I do that and then press compute, what I have is 2.326 is a value right here, such that if I get a test statistic z greater than that, I will then reject the null hypothesis. Anything beyond here would have a p-value less than the 0.01. So my critical value will be 2.326. It says rounded 2 decimal places, so 2.33. So calculate the test statistic. So here I'm actually going to run the test. So let me close this. I'm going to run the test. So since I am doing a proportion test, go down to proportion stats, one sample test, and I have the summary statistics. So my sample size is 120. The number of successes is going to be 20% of the 120. And so 20% of 120 would be 24. I get that by just multiplying 0.2 times 120. I'm conducting a hypothesis test where the null hypothesis would be that it's equal to 0.19, and the alternative is it's greater than 0.19. So if I want, I could plot the p-value. So let's press compute. And so having done this now, my test statistic, the z statistic here, appears to be rounded to 2 decimal places, 0.28. 0.28 is not greater than 2.33, so we're not going to reject the null hypothesis here. So here says, part B says, do not reject the null. There is sufficient evidence that P is greater. That's false. Do not reject the null. There is insufficient evidence that P is greater. So our test is significant. We reject the null hypothesis. There's insufficient evidence for the alternative. And then in part B, they're asking for the p-value. The p-value for this test that we just ran with this sample turns out to be 0.39. And so that's the best I've got, 0.39. and we're in good shape.